So just as the, whoops, I got to click got it first before I can, okay, perfect. So just sort of as the backdrop, as Sarita mentioned, the ARENA project sort of emerged from the Connix Research Center. So this is an SRC funded, which means many of the US semiconductor industry as well as DARPA funded research center that was sort of looking towards the future of distributed computing. And one of the sort of big applications that emerged over the first year or so of the center was really this idea of immersive computing and being able to have XR applications that, you know, run anywhere between headsets to components in the environment and sort of stitch together the user interface side of mixed reality, but also connect with things like industrial IoT. And so you'll see a flavor in the ARENA project that it's a bit about bringing all of these components in a distributed compute environment together. And sort of the, I think what really excited people about working in the mixed reality space is that we saw a bunch of really promising applications that had been emerging, you know, anything from gaming to IKEA Place, to sort of medical systems. But for the most part, all of these were very monolithic. They were sort of vertically built or horizontally, depending on how you define that, and linked to a particular platform. So we sort of had this vision of, can we get to this world where we have a single cohesive environment where we can run applications can run on different people's hardware, applications can run in the environment, but they're all basically projecting into this common space. And of course, that brings up challenges with the system needing to be cross-platform, and that you need to have sort of coordination and persistence to make these applications collaborative. And you ideally don't want to really overburden application developers when you're trying to do that. So we sort of stepped back and we saw that there was a lot of work and activity going on in the spatial web space. A lot of these companies that are working on sort of web platforms. And for those that might not be familiar with the web in the context of immersive and spatial computing, it's perhaps worth walking through sort of, at least at a conceptual layer, why this actually makes sense and why a lot of people think that XR is sort of the future of the web. So if we look at sort of what we mean by spatial web, the idea is that you have content in the same way that we do in the traditional web, which is sort of HTML descriptions of a web page that you want to show somebody. In the spatial web context, the other component there is the real world. So something around the notion of reality capture. You take this content and the idea is that you have a bunch of different platforms that the content can run on. So in traditional web, it might be a desktop, a laptop, a mobile phone, a smartwatch. The idea behind the web is that depending on your context, depending on your platform, you render this content in a platform specific way. In the spatial web, that's of course in the traditional web that's done with browsers. In the spatial web, we actually also have reality browsers or interpreters. So some of them are sort of the usual suspects like Mozilla, Microsoft, Google. There are a couple of sort of newer players around. So Oculus, for example, has a version of Chrome. Firefox had Firefox Reality. Now I guess it's Wolvik. The fox became a wolf. But there's a bunch of folks that are working on sort of these reality browsers. And kind of the interesting thing that we see is the interpretation now of how you see this content can change dramatically. So if I'm on a desktop, for example, I might see a 3D scene that I walk through where I'm, you know, controlling with the keyboard or clicking the screen to navigate. If I'm in VR, I see something similar, but it's much more immersive. Or if I'm in a full augmented reality, mixed reality platform, I might actually see this content now anchored into the physical world. So much more like what you would see with HoloLens or Magic Leap. And to sort of give a really simple example from the ARENA and from our lab, here's a screenshot of a sort of spatial web scene. This is actually a plant rack that's in my lab where we have an app that keeps track of when plants are watered and fertilization level. It doesn't really matter what the application is, but the idea is this is depicted in a web browser that you can connect to with a URL. And so this would be sort of the traditional desktop web version of it. That same scene you can see in VR. So if you open up an Oculus Quest, an Oculus browser, and you type in that same URL, you'll see the VR version of this. And, primarily the difference is, yes, it's more immersive, and now you've got hands as controllers. So maybe that's easier to interact with, but it's very similar. The interesting thing happens when you open it up in a mobile XR browser platform. And in fact, part of what Connix has done is we picked up a Firefox project that was making an experimental web browser, WebXR browser, and we have sort of our fork of that now in the Apple App Store. You go to the same scene, and now that same content, through relocalizing the device in 6 degrees of freedom, is actually overlaid on the real physical space. And of course, if you open that up in something like a HoloLens or a Magic Leap, you then get that like truly immersive sort of holographic experience of what we're trying to move towards. So this sort of gives you a sense of what we mean by web, spatial web, and why this cross-platform and sort of combining of applications is so important. And you can sort of see hints in this example. You can see the plant application is running. There's a bunch of copies of it. There also could be an access control application for getting into the door. So again, it goes to this vision of having this one uniform interface into the world. And of course, this brings a whole bunch of new systems challenges. We need to be able to do instant localization. We need to be able to do content discovery. So for example, traditional DNS probably doesn't make as much sense when you've got such a reliance on physical connectivity to the space. We want to be able to do low latency sharing of state. There's a whole bunch of sort of interesting security and privacy implications that come up. Who owns these objects? Who should be able to see them? Who can interact with the objects? You want to be able to have kind of spatial and immersive access control. Obviously, you want to be able to host lots of different applications. They're multi-user. This becomes a gigantic distributed content management issue. And then ideally, we want to move to a world where programming and authoring these types of environments is much more simplified. So the idea of just building monolithic apps in Unity for one-time use doesn't translate that well into this type of environment. So sort of getting to what Arena does, the goal behind Arena is make programming and hosting of these distributed multi-user mixed reality apps sort of as simple, although I'd say as accessible, since web is actually not simple, but as accessible as the web. So something where you can really build applications run everywhere. In this example, I show some of the high level components. I'm going to dive a little bit more into the architecture. But the idea here is that you could have multiple users, they're interacting with XR content. So the stuff in the middle is supposed to be holographic. And then you have a bunch of sort of devices that are on an interconnected bus. And so part of what Arena provides you is a distributed runtime. And by that, we mean somewhere where you're hosting the application logic for your XR application. So this is a little bit different than when you think about a runtime in terms of the actual engine on a particular headset. So this is, again, for hosting the applications. We have a persistence database that basically makes it so that when users come and go, they can see a consistent version of the scene. If you launch an application and place some graphics in one location and you leave and somebody else comes back, they want to be able to still see that if it was designed to persist. We also have sort of an access control system built around this. So, people can take ownerships of scenes, they can take ownerships of items within a scene. And when I walk through a little bit of the details of the architecture, you'll see we can go down to quite a fine granularity. It does become harder to manage at that level. And then maybe one of the other sort of interesting differentiators is we've spent a fair bit of effort focusing on how to connect sensors and actuators into mixed reality environments. So the idea of having device tokens for provisioning sort of spatial computing applications that run on the edge was a big motivator for a lot of this work. So I'm going to walk through a bit of an example with a diagram of sort of what Arena does and a little bit of how it works. Then I'll show some example videos and demos and that type of stuff. But so to start off with, imagine we have two users that are in a space. We have some things that are physical. So this is actually a real table. So when a new user joins, the first thing you'd want to do is discover the content in that space. And we have a service which we call the Atlas that does this sort of geographic lookup. And I'll get to this later. We're actually reworking the atlas entirely, but for now, it's basically a sort of simple spatial database lookup that tells you these are scenes or programs that are near you in a physical space. So you get a list of these scenes. Most importantly, you actually get an edge server that you can connect to. So you find a compute resource that's embedded in the environment. So in this case, there might be a Raspberry Pi that's hosting a bunch of applications in an office or something like that. So then what happens is when the user, perhaps launches one of these applications, you get Arena programs which run on the different runtimes that are available connected to that particular realm or broker. So in this case, you might have some programs that run on the embedded computer, but you can also host and launch programs on the individual headset. So like personalized programs that are specific for you, maybe they run on your headset. Programs that need to live and persist in the environment because, they're monitoring a industrial control process. They would actually live in the runtime that exists on that machine. But again, anybody that comes into the scene gets on sort of a cohesive, consistent view of that world. So this is all represented in a scene graph, which would be pretty common for folks that are sort of in the graphics community, with a couple of differences. One is that we have not just the geometry information in the scene graph, we also have information about users and their IO. So we call this sort of a network transparent runtime. So anybody that's connected to this particular pub sub bus can basically send out commands to draw content and actually receive IO from that content. So if somebody clicks on it, the program receives a message. So let's walk through a little bit of how that works. So let's say this program decides it wants to draw content. It sends a message out on the bus that tells the other clients to actually draw the content. So you get this 3D chessboard. And then over here, you can sort of see, okay, that chessboard is an entity that's been added into the scene graph. If a user clicks on it, that click input basically goes back out over the bus. It's received by the application, and the application sees which user it's coming from. So you get the sense for if you have access control of who can read, write, and execute within this tree, you can kind of scope the access permissions of how people are using the system. So the user clicks, the program responds by saying, here's an update. I'm going to draw like a click something event. And that again shows up in this tree on the left side as sort of an action for geometry creation. And then the interesting thing is you could imagine having a new program that comes in, and in this case, it's a second program running on another headset that also coexists in this ecosystem and says, I'm going to draw a new object. That object is going to be reflected. And in fact, it's worth pointing out that since all of the IO kind of goes through our standard geometry user interface bus, these programs can even interact with each other. So you can have agents that are talking to each other in this space. So that's kind of a little bit of a sense of how it works. I'll show a quick example in mobile AR of an early version of what this looks like. So here's opening up this WebXR browser from Mozilla. And you basically, this is a quick lookup that's telling you these are the scenes that are near you from the atlas. You switch into AR mode, it's going to relocalize based on that April tag on the floor. And what you're going to see is this is another user in the scene that is again implicitly networked. So they're represented by a camera. In this case, it's an avatar head, but they're also interacting in the scene. If they look at me, they see the same head. I'm now going to look down and I'm going to launch a navigation program. I'm going to click on that application that's running and it's saying follow the line. The other thing you can see is a different application that's sort of linked in with a lighting control system. So this is another application running in the scene, totally independent, that's being multiplexed with that navigation application. And so you can sort of walk around and interact with, in this case, it's a Lutron lighting controller, but it could be any number of other sort of IoT devices. And to sort of drive home the fact that this is multi-user, here's an application that's being executed from a Raspberry Pi wirelessly that two of us are now interacting with. This is just sort of a simple tic-tac-toe game. And you can see that that application basically has no notion of how many users are interacting with it, but simply because of the sort of implicit networked nature of Arena programs, you can have anybody that sort of clicks and interacts with it. That's transparent from the application designer. And you can see little hints in the background of how it's actually responding to the environment as well. And then this is just sort of another instance of the navigation program. And you can see other optical markers for relocalization. And we have a couple of other tricks that we do for relocalization that are sort of built into the Arena framework. So to give a quick sense of the architecture stack, what this looks like in terms of software chunks. So the Atlas geospatial directory sort of lives out here. I'm not going to focus a lot on that because that's actually a work in progress. We're talking with folks at AR Cloud and thinking about sort of re-architecting how that works. But the idea is that connects you to an Arena realm where you have some computer that's able to basically host some of the backend services that we have. It provides basically two communication channels. One is a publish subscribe bus, which is a modified version of MQTT. So we use MQTT. We added some provisions to support access control tokens. We also have REST. So basically all of the content you just grab over sort of standard HTTP REST requests. So the main services that run on the sort of main hub or controller for that realm include things like a runtime to be able to host programs. And I'll talk a little bit about this more later, but we actually use WebAssembly as sort of a transport layer for a lot of our programs. It's really nice in being able to securely sandbox sort of unknown foreign executables. We have something which basically is a supervisor that decides how to schedule and map those tasks across the network. We have something that's looking at authentication and access control. We, of course, have a static web server that can just sort of push out the content and the basic material. And then we have a sort of persistence data store, or a stenographer that's sitting there watching the bus, keeping track of the state. And then when new people come into the system, they can get sort of the latest update of the state of any of the different scenes that are executing. On the actual viewer device, so this could be a headset, a tablet, whatever it is, we're very much leveraging existing awesome web stack tools. So we're using WebXR to manage the actual sort of tracking the camera and click interfaces and all of that good stuff. And then the Arena web client interface is basically built on top of a framework called A-Frame, which is from Mozilla. It's built on top of 3.js, which is built on top of WebGL. And this is an entity component system that basically allows you to manipulate geometries. And so what we do is we provide that networking layer on top of it, as well as some of the bells and whistles around access control and persistence. And then each device in the system as well can also host a runtime, so that once they've connected to this realm, these programs can actually get dispatched directly to headsets if you want to, for example, reduce latency, or if it's a program that's only pertinent to a single user. So that gives a little bit of a sense for the stack. And then, of course, we have support for headless devices. So this would be little Linux boxes that have no graphics capabilities, but they're basically just there to run application logic, and maybe they're keeping track of their own state for some application. So a good example of this would be that lighting application that I showed in the previous video. That would be very much something that operates on a headless device. Also, the tic-tac-toe game was coming out of a headless Raspberry Pi. And hopefully you guys don't have a lot of background noise. There's like construction going on outside. Here's a little example of
actually, can I ask a question here?
Absolutely.
Yeah, so can you give me like a concrete sort of instantiation of what's a realm?
So a realm is basically our definition of a tightly closed server infrastructure. So like if you yeah, I apologize, this is getting really noisy outside. So a realm would be an endpoint that basically runs any of the Arena services. So if you wanted to, for example, host a bunch of scenes, have persistent data store, have like a particular Arena instance that you're running on your own premise, like in your office or something, you basically set up a server. The realm would be the server endpoint for that. When you connect to like arenaxr.org, we have one sort of large realm that people can interact with, at least over VR, over the internet. But the idea is that realms can be connected with each other, but they're also sort of isolated. So you can think of a realm as kind of an on-premise server endpoint for an Arena instance.
Is it almost, that's like conceptually the security realm as well, right?
It is actually. That's sort of why we adopted that name, and it basically means that for this particular realm right now, you have that sort of authentication and access control that's embedded into it. There are of course ways that you can federate that later, but right now it's actually contained to a particular realm.
Is this like based off of LDAP realms kind of? Or
not directly. So no, we're not using actual LDAP realms.
Got it.
In fact, for our authentication, we use sort of OAuth, and we create tokens, JWT tokens that you pass around that are sort of capability based.
Okay, thank you.
And so
And actually, Mike is on the call. He designed a lot of that stuff. So if you want to say something as well, feel free to chime in.
Yeah, no, I think you got the gist of it. I mean, the topic structure of the MQTT bus, your messages, you were able to control the access to various sets of topics, including realms.
I'm just curious, like, who is the root of trust in the system, and how do you update that moving forward? Make sure that you own the realm and it doesn't get hijacked, and all sorts of interesting things like that.
Yeah, at the moment we're linking into like Google OAuth 2 and doing a type pairing based on the tokens that we issue. But we have a lot of ideas about how to create a better federated version of that, and
Yeah, I'd be
that kind of
super
thing.
interested in that
Yeah.
direction you're taking. Thank you.
Sure. Yeah. Thanks.
Can I ask on the transport layer here? Just I see that you've got a pub sub model and an HTTP REST model. What is kind of the agreed contract between these different apps? You mentioned you had the Light app and the Tic-Tac-Toe app. Is it just message passing? Like you do a broadcast of a particular contract, and if somebody understands what that is, they respond to it, or how do these things communicate?
So it's a little bit of that, but it's probably slightly more in that we have a relatively standardized structure of how applications and messages fit together. So for example, if a user is interacting with an application inside of a scene. So one thing I don't mention here is that a group of applications running within a single security domain is called a scene. And so a realm will host multiple scenes. So you can think of a scene as just a group of applications that's provisioned by a particular user. But the idea is within a scene, applications know if they're getting a message from a particular structure that looks like a user, that looks like a mouse click, that it can understand what that is, who it's coming from, and what those messages look like. So there is a bit of structure there. In terms of the access control to who can actually see an application or not, that comes from the token that's given to the client when they connect to our broker, and our broker filters that at the server side. So if somebody connects to a scene and they're allowed to see one application and not allowed to see another application, that's built into that capability that they got when they connected to the scene. Is that answering the question? I'm actually, I feel like now that I think about it, I could have interpreted your question a couple different ways.
No, it was less around the security model and just more about thinking about the way that we abstract, real world things here. So you could go all the way down to there's an event that's a mouse click, and then anybody responds to that by doing a raycast or whatever. And then there's much higher level constructs, like there's this well-defined thing called a media player that accepts the URL for content, right? And I'm trying to understand, like, at what layer does this network provide the abstraction?
It's interesting. So it's a bit higher up the stack. So if you're familiar with sort of this web stack here, so low level geometry primitives is much more the land of WebGL.
Yep.
A-frame has things like load a GLTF file, load a audio clip, load a video, texture, map it onto a surface. So
Yep.
we're much more at that layer of abstraction. So you could, for example, load up an object and connect a media feed to it. And in fact, actually, Mike is he's currently working on some cool stuff where he's linking in live 360-degree cameras to spheres that people can sort of click on, and then they actually see around inside of a live 360-degree video feed. So definitely higher on the stack. Probably the lowest level primitives that we have are you can draw triangles if you wanted to do that, but that would be a very inefficient way to create a model. You wouldn't want to do it triangle by triangle.
Yeah, no, and I was thinking more along the lines of the programming constructs, the activities that you would want to do. So
Yeah.
last question, then you mentioned kind of an A-frame layer level primitive sort of thinking. Then how does that work if you have other runtimes? Like, does this work in a Unity environment? And then do you just map all those constructs over to that different runtime?
That is a fantastic question. And the quick answer is yes. So we do have a Unity runtime target. So you can write an application in Unity. And the idea would be that would very likely run as a headless target, probably not in WebAssembly right now. So we wouldn't get some of the nice security and transport properties, but you can take a Unity app and basically run it bare metal on a headless device, and it's going to connect with the rest of the system, provide IO in and out, and function like a sort of standard Arena application. And this was critical because right now, the world wants to develop with Unity, at least to get started. But I think what we provide to that world is kind of interesting in terms of how to organize and structure these multi-user agent-based programs.
Yeah. Okay. Thank you very much.
Cool. Yeah, no, these are all great questions. Okay, here's an example of two mobile users who are again running a program called AR Builder. So the idea is they can basically place models, they can manipulate models. And again, here I basically just wanted to show the naturally network connected component here. You've got two users, they're using their own little control panels. And on the right side, you sort of see the VR version of that world. So on the left, you've got two that are in AR collaborating in real time, but that of course is being mirrored over into the right. And you can even see like the cameras, we've actually changed the graphics since these early videos, but they're these sort of creepy ghost looking heads. And so again, this is sort of the level of primitive manipulation you can do. You can change colors, you can drop in models, you can scale them. Those are all commands that go over our geometry bus, and they're all sort of largely coming from A-frame structure, which is actually extremely well organized and pretty clean as a reference point. Okay, so I want to talk a little bit about the runtime underneath. It's actually running this. So from looking at it from the Connex Research Center perspective, this is sort of a really interesting playground for highly distributed interactive apps that have a mixture of persistence, linking with the real world, linking with users at runtime. And our hypothesis here is that we need a programming model and a runtime approach that obviously is distributed, but is also sort of focused on security and timeliness. And so one sort of shift in the way we do a bit of our thinking and our design is if you think in terms of a typical process on a computer, even if it's in something like a container, you have a bunch of the logic that lives in the application level, but then you have a bunch of the state that's sort of in the kernel land. You're keeping track of file descriptors, you're managing sockets, all of that type of stuff. That makes it very hard to sandbox and isolate these applications. And, the cloud has done a good job of that, but it's relatively heavyweight, things like virtual machines. What we would like to do is really have a very thin layer of communication such that our processes keep the state and connection information that they need locally, don't have this reliance on state being stored in the operating system. And that makes them much more agile and mobile. So you can basically imagine, as long as they know the name they're looking for in the pub subtree, they can jump around and move to sort of any computer within any network connected computer within the space. And by sort of one of the benefits of using WebAssembly as our lightweight virtual machine abstraction is we've even been able to show things where we can actually do a context swap, where we can freeze the state of one WebAssembly program and actually migrate it over to another machine, over to another computer, and then relaunch it live. And WebAssembly is relatively low overheads. You can actually do that at realistic human timescales, which is kind of an interesting property of the system. So we have a bunch of work around this. We call them nano processes. I think this is a term coined by the Mozilla folks as well. But the idea is we have this now, we're working on this orchestration system for managing runtimes at the edge, scheduling them, keeping track of sort of network usage, CPU usage, IO usage. And we end up having this sort of nice graph of the platforms with a list of the different applications and where the data flows are going. And so some of my students are now looking at how do we optimize that placement within the system. And again, just sort of looking ahead to thinking about Elixir, this could also now be something where we actually link this with some of the resource management and monitoring that Elixir is doing on the actual single unit runtime platform level. So I think there's sort of an interesting connection to be made here. Okay, so actually I want to show some code, not too much, but this is an example of a Python program that can actually run in the arena. And to make a long story short, this may sound crazy, but we have a Python interpreter that we compile into WebAssembly that can run these programs interpreted. So they're actually running as WebAssembly agents in the system. But you get an example of sort of what the code would look like. You create an object for like the Earth at a location, the moon here. So this is going to be a moon circling around the Earth. And you can do, simple Python callbacks for animations and things like that. You can also, of course, build a Unity application, which, probably won't run in WebAssembly right away. Or you can actually, write any program you want and just send out the raw messages that the arena accepts to communicate. But this is sort of the easiest ways with a Python application. And I don't know how much, if it's worth walking through this, but this is kind of an example. 2 web browsers open on a single machine. These could actually be on different machines. And you can see that, if I scroll around in one of the web browsers, you see the other one reflecting the updated position of the head in the network connected environment. I'm going to run that Python program on a Linux box. It's going in for OAuth. It's grabbing the token. It's getting the JWT capability. And now it's able to actually paint. That program is now painting into both of these browsers. And so these could be running on any number of different machines. Then I'm going to go into a different terminal. So, pretend this could even be a different machine. I'm going to run another Python program that's going to draw green boxes everywhere. So you get a sense for how these programs are now interacting with users sort of seamlessly. And it's worth keeping in mind that this whole thing can be anchored in reality. So in this case, it's also running in the lab in AR. And one of the sort of recent things we added because of the pandemic is we actually on the web client, we connected with audio video. So users in the scene from the browser side can actually have a video feed with spatial audio that can walk around and sort of interact in VR, which is kind of fun. And I'll show examples of kind of where we went with that in the next couple of videos. In terms of anchoring content to reality, we started off with optical markers. We have also built plugins for Arena for external trackers. If you want to use an OptiTrack system, no problem. And then my group actually does a fair bit of work in GPS denied position navigation and timing. And so we have a bunch of cool things emerging around UWB and radar chips that we're building that also actually work with Arena. So we have the ability right now to use ultra wideband RF time of flight ranging radios to sort of set up ad hoc arena scenes if you carry around a tag connected to your phone. And now with the U1 chipsets and a lot of phones that are coming out, UWB for Android folks, we think that that'll become sort of commonplace. So a merger of RF time of flight ranging mixed with sort of visual and LiDAR based relocalization. So to show kind of one example, once we added this video feature, this is a clip from the annual review at Connix, where a team from UCLA was showing some control algorithms that they were designing for a UAV. They basically have a mirror of that UAV projected into Arena, and they were actually working on distributed control using the runtime. But for the demo, they actually built out a scene in Arena that everybody remotely connected to, of course, pandemic times, where you can see a live video feed sort of texture mapped onto the walls. You see people walking around talking with each other. They can actually see the digital representation of the controls demo that was running there. And it was just one of these like wild aha moments of like, wow, this is so much better than a 2D Zoom conversation. And it just like, that really started to spark a bunch of people's imaginations. And that led us in a direction where we've started to do more merging of virtual and physical spaces. These slides are in a weird order. Before I show you the merging of virtual and physical spaces, it's worth mentioning we do have sort of Unity and Blender support for authoring. It's still sort of early stages, but this is something that we're definitely seeing a lot of interest from the community to like make it easier to actually author Arena programs. And Mike has been sort of the mastermind behind a lot of this stuff. So if you have questions, you can actually ping him. So here's sort of an example of taking that concept of virtual and physical spaces and mashing them together sort of to the extreme. So we did this for this competition that ISMAR had. So we start by scanning an environment with some visual markers in the place. So that was a Leica BLK 360 scanner. We get a 3D model of the space. So this is just us poking around in Blender. And then you can imagine joining that space in VR. So that was, I'll go back a little bit. This was my student Artur, who's in VR. He's moving around. You can actually see in the web interface, like this is his video looking at him. This is what he sees. And then he's got buttons for, muting video, all of that stuff. Somebody can also enter the space in AR and actually directly see and interact with Artur. And he sees them as a floating head with a tablet. We've also taken things like Magic Leap headsets with self-facing cameras to sort of show how you could have a speaker projected into this 3D space. And here, of course, you're looking at it in AR. So you see some mixture of people who are remote, some people that are physical. The physical people have their laptops open, so they also show up in the space. So really just sort of exploring all of the wild ways we can do these virtual physical reality mashups. And here's kind of just a snippet of that, which is a fun one. So this is Ivan, again, one of our lead programmers on the team. He is walking around with his mobile phone that has its front-facing camera on. So you can see a portal that's aligned in the real world, showing the scan of the digital world, where you see what a VR person would see for Ivan in that frame, right? So he's seeing his camera. This scene capture here is the VR world, and you'll see he walks through, and there's actually a fun little photobombing thing that happens, which is Mike Farb, also on this call, was sort of stalking in the background, and he's in VR land. And so you can see him in the background. And then as Ivan continues to walk through, you look from the other side of the portal. Of course, it's double-sided, and you see that's again sort of the VR version of what people would see. And this is just super fun to do with HoloLens or Magic Leap, because you really see like remote people's floating boxes. It's got spatial sound, so it's coming from the right direction. So just pretty neat. And of course, Arena is making this whole multi-user, multi-connection, sensor actuator stuff much easier to author and pull together. So that's sort of my quick overview of Arena. And if you guys have questions, I'm happy to take them. But what I'd like to talk about a little bit is sort of the potential and what we were thinking in terms of connecting Arena and Elixir. And we've been thinking about this in sort of two phases, right? We definitely you want to be able to walk before you can run. So in phase one, the idea was, well, maybe phase one is running before walking, because we just want to get it running. But in phase one, we want to get Arena basically acting as an XR application for Elixir. And we actually think that this should be pretty doable. We've seen some of the work of the Monado crew, and there have been people who basically showed using WebKit being able to run WebXR on top of Monado. And so sort of as a first step, like get the pieces together. We believe like, hey, let's run Arena here. You can imagine Arena applications then being hosted on top of it. So the utility of this is really, it starts to give Elixir an example of a bunch of different spatial web workloads, which I think is important. That's something that we care a lot about and would like to be optimized. It also perhaps helps with connecting external IO and components in and out of Elixir. And from our perspective, it means that if we have like a cool new localization technology that we want to bring in, we don't have to do crazy hackish side channel things within web browsers. We can in fact integrate it directly into the Elixir stack. And of course, the obvious byproduct is we'd have multi-user XR experiences that we could start playing with and exploring some of the really top level things like security and privacy and what those rules and regulations should look like. So this is a very near-term goal. I feel like we can have this done pretty quickly. The interesting thing I think comes in what I'm calling phase 2, but basically doing a slightly tighter integration of Arena into the Elixir communication interface and runtime. And so this is a very quick diagram, and we need to, of course, flesh out and hash out more detailed versions of this. But the idea would be, if you can bring Arena closer into the Elixir communication interface and runtime system, then Arena apps still sort of live at that top layer. But what this allows us to do is everything from phase 1, obviously, but it also allows us to explore joint resource scheduling and mapping between what's happening on the headset, the heavy graphics XR workload, as well as the sort of distributed compute workload. And the cool thing there would then be thinking about extending that to like hybrid cloud edge rendering. And I don't know, there's a whole bunch of sort of interesting, neat ideas we've had if you could do really that co-optimization, co-design. So that's sort of phase 2. We've got a lot of talking and whiteboarding and a lot of back-end work before we think we're going to get there, but that's sort of the vision. Cool. So sort of in conclusion, as the metaverse starts to get more physical, whatever you want to call that, meta Earth, we definitely think that spatial web technologies are pretty awesome and could help be a sort of a key role in tying that all together. And I think it just opens up all of this opportunity to rethink OS design, compute infrastructure, doing co-design through hardware and accelerators to sort of tie all these things together and make them efficient and really get to the point where we can have, wearable headsets that people use outside of just gaming, things that become sort of critical and integral to everyday life. And wanted to just thank everybody in the Arena team, and also thank, of course, all of the sponsors from Connex and SRC that made all of this possible. Cool. So thanks.
Thanks a lot, Anthony. That was awesome. And really looking forward to integrating Arena and Elixir. That'll be super cool to have an end-to-end open source distributed platform that people can, the whole research community can play around with, including us, of course.
Yeah, and I think it's exciting to think about really breaking down that barrier of entry at so many different levels, right? Like fully cross stack. Yeah. So let me open this up to questions. We have about 8 minutes to the top of the hour. Okay, I have Finn here. I do want to introduce Finn to everyone. Finn is our alum. He used to be an undergrad. He's now in Microsoft, and he is responsible. He was part of the original team Elixir, did a lot of work, and in particular, reprojection, time warp, space warp, etc. That's all Finn. Yeah. Good times. Thinking about all the good times, Finn. So do you have a comment?
Yeah, this is fantastic stuff. I mean, all the application layer stuff is one thing, but all the WebAssembly container talking to each other over the pub sub bus, that's phenomenal stuff. That's really the missing piece for all this, because the fact that you can have these little WebAssembly containers, both running as like your typical, web app sort of thing, but then also as an IoT, like this is just the drone can have its own. That is fantastic stuff. Yeah.
Yeah.
Congratulations.
Oh, thanks. That's definitely sort of the intellectual meat of this, right? It's rethinking what happens when you have lightweight VMs and agile processing that you can just shuffle around a distributed compute environment. So yeah, it's something that we're excited to, we're continuing to develop it. We're pushing it further. We're trying to actually get it into some more industrial applications. And then it brings out a beautiful XR interface almost for free, right? So
yeah, I was wondering about that Atlas service, the relocalization system. Is that using some kind of, because I know, for example, on the Microsoft side, the like our Azure Spatial Anchor system, right? It uses sort of like this fused thing where it uses point cloud off the sensors, but then it fuses it with like GPS and past fingerprints and all that. So is that sort of what Atlas does in the way that it combines GPS with like point cloud fingerprinting?
That's the vision of where we're going. And
Okay.
we've looked at sort of Azure's anchors, and we've looked at a little bit of what is it Lightship from Niantic? I think it's called Lightship.
Yeah.
Lightship. And there's a bunch of these sort of sensor fusion, relocalization lookup things happening. That's part of it. And in my group in particular within Connix does a fair bit of work on sort of sensor fusion and SLAM and all of that. Maybe one simpler thing though first is really something more like Uber's H3 sort of geospatial database lookup. Like how do you store URLs in a distributed manner with something maybe like a geographic hash table, but where you can actually federate access for spaces, right? I want some way of being able to say who should be able to host a server that's controlling content in my office, and like how does that become visible to users, and what does that whole process look like? And it's interesting because I think there's a lot of policy around it, but then there's also just the technology that backs it that scales. So it's a combination of those two things.
Fantastic. Thank you so much.
Okay, we have Mike with his hand up. Mike Buford.
Yeah, the question I had kind of was answered by what you were talking about, but I was trying to understand with regards to the, actually, I'll come back to it. I want to rethink it.
Sure.
Yeah, Jared.
Yeah, thanks. I guess I could turn on the camera here. So thank you for answering those questions earlier.
So I guess if you don't mind, could you also introduce yourself? Because I think.
Oh, sure. So I was invited to this call by Finn. I work at Microsoft as well. Been in the HoloLens side of things for quite a while. And actually, it's funny. Finn was telling me that he found out about me because of work that I had done on some looking glass stuff, which was actually just fun holographic stuff on the side. So cool. But I guess my question is kind of similar to Finn about this management of space. And you talked about, a scene and I forgot the other word that you had there, but how do you, what is the granularity here? Is the granularity, a building, a room? What happens when you go from space to space? These are all, even if we look at a device like HoloLens, which has fantastic spatial mapping, at some point you're going to turn it off and you're going to go to another building, and then it doesn't know where it is relative to the last space that it was in. So how do these apps know, and how do you know when you've crossed spatial boundaries?
Yeah. So again,
actually, if you don't mind, Anthony, before you answer that question, since we are hitting the top of the hour and people might need to drop off.
Sorry.
No, just a quick announcement that, if people are interested in talking about this more, we can, Anthony and I are going to be continuing this for a while. Please reach out to us if it makes sense to form a working group to address some of the issues that are coming up. We can do that. We'd like to facilitate that. So please reach out to us on the email that you have. Okay, sorry, Anthony, go ahead.
I mean, I actually feel like this discussion about how to manage geospatial information is really key. And I actually would love to chat more with the Microsoft folks. I think you guys are really ahead in that space. I don't have all the answers to your questions. The way we do it now is relatively simple. You have a URL that links you first to a realm. So a realm is a server for a relatively large area. So for example, all of CMU has a realm, all of UCLA has a realm, all of Berkeley has a realm. Then within the realm, we have scenes that typically are mapped to like floors or office space sized areas. There's nothing conceptually that stops them from being larger, but you're right that most of these systems run out of memory for holding, dense maps. And so like, you're not going to have a scene that goes across all of CMU's campus that runs well on any device actually. And so typically in those cases, when you cross boundaries, the localization system knows that there's other scenes that it can find. And so at this point, it's kind of up to the user to transition and say, okay, I want to jump to this scene, or if it's the same scene that's tiled, you can sort of automate that handoff. But you really are jumping sort of from scene to scene as you get to bigger spaces.
And those URLs, are they discovered because you've scanned an April tag, or are they broadcast somehow? Like, how does the device discover which URLs are nearby?
Yeah, so it's a combination of, you can basically represent those URLs as a UUID that's linked to an RF beacon. So you could have a Bluetooth beacon, you could have a UWB beacon, or it's off of a GPS lookup or some combination of the two. So when you're moving from area to area, you're leveraging GPS and or beacons that are placed. For April tags, we actually don't use those to identify the scenes. For those cases, we typically have a QR code that has a link to it, and then the April tag is just for relocalization. I think moving forward, we're really interested in trying to make an open platform that can collect a lot of things like 3D point cloud features, mixed with tag locations, mixed with RF beacons, to sort of help streamline this process and make it truly cross-platform. I've heard interest from a number of folks along those lines. Because right now the nasty thing is if you create an AR session with AR Core and then AR Kit, like they're not compatible with each other, right? You basically have to create world maps that are completely independent. Same with HoloLens, same with Magic Leap.
Yeah.
It would be super cool, and same with Lightship. It would be super cool to figure out how to homogenize some of these, right? And actually create like the full digital twin of the world, if you will.
And,
So
and at
the
some point, you
open-
also have to think about like impromptu things too. You're at a bar or you're
Yep.
in a space and you meet people, and then how do you have an impromptu session that maybe you don't have the supporting
Yep.
RFID infrastructure nearby? So
Yeah,
anyways,
so
okay.
there's there's an interesting twist on that. So the bar case, if you want to play a game or show your colleague PowerPoints, you can build a map, you can share the map, you can do relocalization within it. You guys are really good at that. One fun thing that we've been looking at, we just published a paper on this, is actually using a combination of visual inertial odometry and UWB ranging to set up shared AR sessions with no shared features. And this was something that we were looking at for the IVAS context, right? So we have a DARPA funded project that was looking into how do we create shared multi-user AR without sharing map features. In the use cases, obviously your teammate is running on the other side of a wall. You still want to be able to get situational awareness. But that's actually a really fun problem.
Yeah, for sure. All right, thank you.
So the open AR cloud folks, they are interested in a lot of this stuff. Did you say you were working with them, Anthony?
Yeah, so we actually met them at ISMAR doing the demo, and they were like, wow, this is cool. We're doing very similar stuff. We should coordinate. So we have been a bit. They are building theirs on top of H3 right now, which is Uber's geospatial database. There's definitely some value to that because it's sort of tried and true and it's scalable, although I don't know that it solves all of the problems. So we're chatting with them. We're thinking about it. I feel like that would be like, if we were interested in an Elixir geospatial working group map sharing relocalization type subsystem. I would love to get in on that, and I'm sure they would join as well.
Yeah, so I think Christine has wanted to be a part of the consortium, and that's going to happen. So so that group, we will reach out to them and see, what we can facilitate for sure. Yeah, sounds good. So Mike, I think you got your question here. Do you want to say it yourself or?
Yeah, no, yeah, I'm sorry. I thought about it and I saw that phase 2 slide and I was really interested. You're going through Monado, and it sounds like in order to get the kind of features down lower, you would have to kind of morph Monado. Are you going to make it backward compatible more or less so that if I write something to Monado, it doesn't break?
Yeah. So we actually talk to the Monado people quite a bit. And we're going to have a series of meetings to make sure, that we don't break things. We want, again, our goal is to have a common ecosystem, not to fragment it. And we worked with them in the past as well. So Elixir, for example, is a device on Monado. And we plan to move together, forward together. How we're going to do this is going to evolve.
So hopefully no breaking changes, just you're going to be at additional features that you'll keep adding on as you move forward then.
Well, or make it, so that Jacob and Ryan are comfortable changing something about Monado to accommodate this, right? So where the value is obviously seen.
Yeah, no, fair enough. I appreciate it. Thank you.
Yeah. And then, also staying with in the loop with OpenXR so that nothing there breaks, right? So just making sure that this whole ecosystem evolves in a compatible way.
Yeah, totally. Makes sense. Thank you.
Yeah. Okay. Other questions, comments, thoughts? I think there were some new people here today. If you want to say a couple words about yourselves, that'd be great. We had that last time and that worked out great. If not, I understand we are at the top of the hour already.
And unfortunately, I actually have to drop off, but Mike, I saw Mike posted in the chat just an endpoint for an arena scene. It's just sort of a purely VR one. We have some that are scanned spaces, but if you go there, you'll be able to actually sort of wander around with AWSD or the arrow keys. And if you give your browser all permissions, if you give everything away, then you should be able to actually share video and talk to folks and all that. It's definitely more fun in AR, but unfortunately that's a slightly harder demo to set up at the drop of a hat. But yeah, thanks everybody.
Yeah, I can vouch for this. Do attend that demo if you can. It's cool.
Awesome.
Okay. Yeah. So thank you so much, Anthony. This was great. Thanks. Yep. Looking forward to next steps. And again, people feel free to drop off. It's a top of the hour, but if you'd like to hang out and introduce yourselves, that'd be great too, especially for the ones who weren't here last time.
Cool. Thanks, everybody.
Yeah.
Thank you, Anthony.
Thank you. Bye.
Yes, Sarita, I'll introduce myself briefly.
Yeah.
I'm a CMU research programmer working along the stack, the stack. So you kind of got that, but there's a docs link there if people want to search for some of the questions they have. And we also have we have a Slack that people can join and have discussions.
Yeah, great.
Hi, my name
hi.
is Malesh. I am a postdoc at CMU with Anthony and also Srini Session. I did my PhD just like 2 months ago from Stony Brook University. So I'm also working on the similar area of AR, VR, and volumetric video streaming particularly. More specifically, I'm working on hybrid rendering of volumetric videos, hybrid rendering and streaming.
Oh, okay.
Videos. Yeah.
Okay, cool. Yeah, we should talk about that. Yeah.
Hello, can you guys hear me?
Yeah, hi Javier, how are you?
This is Javier from Intel Labs. A little bit different discipline. I'm a wireless guy looking into these kind of applications. How can we can offload rendering to client devices, and what are the limitations of current wireless technologies for that. So
Yeah, great. And we're working with Javier on some things as well. So looking forward to that, Javier. Javier, if you want to present something in this group, for example, let me know. I mean, that might be an opportunity as well.
yeah, maybe we could introduce WTSN to this group.
Yeah.
And maybe people can think about how this technology could be used in this
Yeah.
context.
Yeah, that'd be great. Yeah, let me know when. I think we're just starting out, so the schedule is pretty open at this point. So let me know.
Sure. Let me ask internally here, and then we'll put something together.
Yeah. Cool.
Good.
All right. Yeah. Thanks for attending, Javier.
Hi, Sarita.
Hi, Tandy. Yeah, good to see you again. Yeah.
Yes, thank you. Actually, I have a question about the arena architecture, but it was too late to ask questions now.
Well, Mike's here, so he's.
I might be able to answer.
Yeah.
Okay. For the arena architecture, it is a distributed XR architecture, and we have a client that does the rendering operations. Am I right?
Yes. Yep.
Yeah, the client do the rendering.
Some clients. Yep.
Yeah, and an embedded computer that provides the arena services, right?
Can you say that again?
A client that does the rendering, and embedded computer that provide arena services. Am I right?
Right. I mean, yeah, many things are baked into the web client, and then we have other client endpoints that you can connect from, say, from our distributed runtime, which is kind of in flux now, as well as running your own Python end client connection or Unity end client connection. Yeah, and then you can create programs that send and read messages into our bus that then can be picked up by users who are using some kind of web client. Yeah.
Okay, so for my question is, for architecture researchers, should we focus on the client or the server side?
I think the server side is more interesting because we're trying to make distributed runtime flexible so that applications can move around the network topology wherever we find that it's more efficient to send and receive messages on the bus.
Okay, but I have another concern that if we have a client that does all the rendering operations, would the energy efficiency would be a problem for a mobile device?
Certainly.
Devices?
Yeah, I think that is the whole idea of trying to figure out how to do the off-device rendering in a way that that optimizes energy, but also deals with the fact that bandwidth is limited or maybe limited.
Right. I mean, this is the one of the other real nice things about Elixir is we can measure how these devices will react, and we can downscale elements of the rendering, either by details or eliminating things that are redundant. If you're not using AR and you're just connecting to a scene, you may not care about what the environment looks like. You might just be listening. These kinds of things we'll have to bake in, but we need some measurement.
Yes. Okay. Thank you.
Cool. Thanks, Tianwen.
Yes. Thank you.
Yeah. Any other last minute thoughts? I have to leave in 3 minutes.
No, I'm going to jump over to the arena. I think someone was there trying to speak to me, but
Okay. All right.
Two
Thanks
calls
so
at
much,
once.
Mike. Yeah. Thanks for attending, and looking forward to working more with you.
Thanks.
Yeah. Bye. Okay. See you all. Hi, Art. How are you? Art, you're muted. I can't hear you.
Yeah, I was just looking for the mute button. I'm doing well. How are you?
Yeah, thanks. We are good. Thanks. Thanks
It was
for
an interesting
attending.
presentation.
Yeah.
The
Cool.
distributed computing was actually very interesting.
Yeah. 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 So that's, hopefully that would be that's the next kind of big phase for Elixir. We have a lot of work going on device, but I think combining with what Anthony's done is going to be really cool.
Yeah, that was interesting. All right. Thanks. I do have to drop off myself though.
Yeah.
So,
Thanks so much. Yeah. Bye-bye. Yeah.
Bye.
Okay. See you. Bye.